Hey guys, so you can either watch this video and take notes with me for chapter 7.1, graphing and functions, or you can read through it on your own, take your own notes. In both cases, you will need to do the checkpoints and will be held accountable for them. So just make sure if you do not understand the checkpoints that you are coming to office hours Tuesdays and Thursdays. It's going to be an important point here moving forward. But 7.1, let's go ahead and get started. There's going to be 6 things we're talking about. How to plot points on the coordinate system. So just kind of thinking back to first learning that in middle school, probably, I think, graphing equations, okay, in the coordinate system, all different types of equations, using function notation, graphing functions, using the vertical line test so you can tell what a function is, and obtaining information about a function from its graph. So kind of everything that you've done around functions and graphs kind of condensed into a little review here. So this first part, I don't want to take up too much time. It's talking about some things you should know about. You have the 4 quadrants. If you have your y-axis and your x-axis, you have quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So just a little bit of vocabulary there. The origin here, of course, is in the middle of the graph, is 0, 0. And you guys can think about maps as coordinate systems, and actually our school is almost at 0, 0 in Denver. Broadway and Ellsworth is at 0, 0, and that is the map. That's where the map starts for the whole city of Denver, so that's kind of fun. Each point, let's see, they're just talking about ordered pairs, and ordered pairs is an x coordinate and a y coordinate, okay? You cannot just have one number to find a part of the graph. If you look at the graph down here, okay, each of these points that are plotted have an x value, right? And I'll highlight that in green. And they also have a y value, which I will highlight in blue. And what you need to remember is that the x value of that point, if you go down to the x-axis, you can find that number, or this 3 over here where that point is. If you go up, that is the 3 on the x-axis, so that's what that point stands for, is where it lies in relation to that x value. And then the y, of course, if you go over horizontally, you should hit that. So here where the y is 3, if you go over from the point, there's 3. And if the y is -5 down here, if you go over from the -5, you of course hit the -5. So just remember that number corresponds to the axis that it is representing. Okay, I think when we were first learning how to plot points, you talked about going over and then up. So you go over is your x and up is your y. And we'll talk about that as rise over run when we talk about slope. But for now, just make sure you are remembering and really comprehending that the number in that coordinate point for x corresponds to the x-axis, and the number for the coordinate point for the y corresponds to the y-axis, okay? All right, so this is all review. I don't want to spend too much time on it and make you get bored in the video. So the example is just like, hey, plot these points. Go through it. I'm not going to spend too much time on it. Let's just do one together. Oh, I can make the highlight skinnier. That's cool. So we have A, our X, and you guys, I always think of our X, Y. The X value always comes first in a coordinate point, the Y second, And I always remember it's in alphabetical order. So A corresponds to A over here because it's -3 for the X and +5 for the Y. So go through that example problem and then try the checkpoint, please. Just make sure you could find all of those points on a graph. You can always help yourself out, check yourself out by taking, if we're looking at that checkpoint, point A is at -2, 4. You can always go to Desmos, the graphing calculator, and like I would just put that in as -2, 4. Okay, and it plotted that point for me. You can even put a label on it, and you can see -2 on the X and then up the Y axis for 4. Cool, cool, cool. All right, graphing equation. So we are talking about any equation, doesn't have to be linear. We'll get into some linear stuff soon, but just graphing any equation, the way it's talking about doing this is that just making a table for your equation. So here, if it's talking about y equals 4 minus x squared, in order to graph it, you can always make a table of inputs. Remember, x is our inputs, and outputs. And then that's why it talked about graphing points. And then once you do that, you should be able to graph those points. So if y is equal to 4 minus x squared, if I make x 0, if my input is 0, and I do 4 minus 0 squared, my output is just going to be 4. So if my input is 0, my output is 4, and I can now graph 0, 4 on the coordinate plane, right? So I could graph 0, 4, let's say go back to my Desmos, make this first point, 0, 4. And that would be the first point of my equation. So we are going to take, last I heard, the SAT in October this year. And I know this is a real quick and dirty way to graph something. So it might be worthwhile, if it's the non-calculator part, to remember how to do this. So let's talk about, what if I don't want to input 0? What if I want to do the next one and I input 1? So now I have 4 minus 1 squared. Well, 1 squared is just 1, and 4 minus 1, my output would be 3. So if my input is 1, my output would be 3. And you're just going to keep doing this and doing this, and then you would graph it, 1, 3, and there would be the next point. Okay, so that's just what it's walking you through. You have your input, you have your output. I believe the example, if you're following along in the book, okay, it has your input here, and then substituting it back into the equation here. Here's your output, and then it writes it as that coordinate point. Okay, this is a great little definition. The graph of an equation in 2 variables is the set of all points whose coordinates satisfy that equation. Okay, so any graph is the set of all points that satisfy that. So most functions go on forever. Actually, I don't know if it's most. Most of the functions that we look at go on forever, positively and negatively. So the graph of that is going to be an infinite amount of points. Okay. Example 2. It is just using, you have your inputs here, exactly what we just did. Here's the equation, 4 minus x squared. So if I input a -3, I would have 4 minus -3 squared, which is the same as 4 minus 9. Your output would be 5. You get the coordinate point -3, 5, and you can graph it. You can graph it in your, oh, -3, -5. No wonder I thought I was going crazy. You can graph it on your coordinating plane, and that point would be there. The vertex, because this is a quadratic, is 0, +4. So that's this point here. If you input 0, your output is 4. And they're just plotting those points and then connecting them so that you can see the shape of the graph. So checkpoint 2, graph y equals 4 minus x. And it wants you to kind of plot the points. You can do that using Desmos. You could quite honestly just type in y equals 4 minus x in Desmos and actually find the table that way, because there's a button you can click on for table. As long as you understand what's really happening there. All right, applying graphs of equations, okay? So what does this look like in the real world? The toll to a bridge costs $2.50. Commuters, so this sounds similar to something we did last section, right, 6.3. Commuters who use the bridge frequently have the option of purchasing a monthly discount pass for $21. With the discount pass, the toll is reduced to only $1. The monthly cost Y of using the bridge X times can be described by the following formulas. So in this case, they're making the formulas for you. So without the discount pass, it's just literally 2.5 times each time you cross the bridge. That's what that 2.5x means. Without the pass, it's y equals, and you start off with $21. You have to pay that out of pocket, but then it is only $1 per time you cross the bridge, okay? So here it wants you to make a table of these equations using these input values, right? And then it wants you to graph the equation, and then it wants you to find the intersection. The intersection of two equations is what we call the solution to that equation. So here they made a table. They have the, oops, sorry guys, your input here, and they used those values we were just talking about, 2, 0, 2, 4, 10, 12, 14, 16. And if I input 0 into the equation, I get 0 back. So that coordinate point is 0, 0. If I input 2 into the equation, my output is 5. Now I have the coordinate 0.2, 5. If I input 4, 10, so on and so forth. Okay, and it looks like this equation matches this line on the graph. They did the same thing with the other equation. I won't bore you. Actually, let's make that a different color. So let's make this equation this line, okay? Now, when you're trying to find an answer to the question, at what point will it be cheaper to spend $21 on the pass, you look at where they intersect, and that's where they cost the same amount of money. So it looks like at 14, so if you use the bridge 14 times a month, you're going to spend $35 using, and it's right here in the table, using either way of crossing it. If you need to cross it 15 times, it will be cheaper if you buy the pass. If you were only crossing it 12 times, it will be cheaper to not spend $21 on the pass. And I will tell you right now on the test, everything comes back to a real world problem. Okay, checkpoint 3, the toll to a bridge costs $2. I mean, you don't even need to know that much. You just need to know that it already made these two equations for you, okay? Graph those two equations, figure out where they cross, and you can interpret what that answer means. Okay. All right. We're getting into, I think, function notation is the part that is next. Okay. And what they're doing is they are changing our output. Instead of y, they are changing it to be f of x, okay? And all f of x means is the function, f stands for function, the function output, the function output when x is a certain value. Okay, what is the output when x is a certain value? That's what function notation means. So you say f of x. What is the output of the function when x is a certain value? When you are inputting a certain value for x, and then you have your equation, right? So what is the output of my function when, whoops, I thought I was in highlight mode. Let's change colors. So this part here is, what is the output of the function if my input x is 10? That's what this means. And this side is where you're actually doing the computation. And this is your answer. When your input is 10, your output is 25. Okay, when you input 10 for x, your output becomes 25. Okay, and the book says make sure you know this means you read this as f of 10. And you do need to know that because when we move forward in any of your math classes, many of your professors will just say f of 10, f of 5, find f of 6. That means solve that equation when x is 6. Okay. So down here, it just kind of shows you the two different ways to look at it. You can always use y equals in an equation. You can only use function notation if you know you're using a function. So, and we will get to how you know something is a function next. But example 4 is using function notation. I will just go through maybe one of these for you. I don't need to read it to you. You can do that on your own. But if we look at A, it says find f of 4, okay? Using the function 2x plus 3. So if we are inputting 4, we change f of x to be f of 4. Okay, that means we are inputting 4 for x. Then the other side is where you're actually doing the math. So we make x 4 here. 2 times 4 is 8. We're still adding 3 on. 8 plus 3 is 11. So f of 4 equals 11. If I input 4 into the equation or into that function, my output is 11. And up here it has the function machine, or that they always kind of show you as you input something, then the function does something down here, and then you have an output. Okay. Oh, let's just do the next one here. We want to find, g of x. So it gives us a function g of x is equal to 2x squared minus 1. G of negative 2 means I'm going to input negative 2 every time I see an x. And then you do all your functiony stuff over here, and your output should be 7. If your input is negative 2, if you put negative 2 in for x, your output should be 7. Please read through how they found this on the right-hand side if you need to. And I think you guys can do C on your own. Just read through it. The answer is right there. Make sure you are understanding this checkpoint. I will get you started on A, but what this means is f, this is for a, f of 6 is equal to 4 times 6 plus 5. And you should be able to just enter this into your calculator to find your output. All right, an application involving function notation. It's entering in all of these points and creating a line, just like we were doing before. So the first point, or one of the points, is going to be 35. If your car is going 35 miles per hour, the required stopping distance is 160 feet. So they just plotted that point here, 3160. Then at 65 miles per hour, the distance required is 410 feet. So that would be the point right like here on this graph. It looks kind of exponential. What is the question? Use a line graph to represent stopping distance at various speeds. Okay. So the first thing they are doing, sorry, keep moving. That's probably driving you guys nuts. Oh, it has questions A and B. Use the line graph to estimate the car's required stopping distance at 60 miles per hour on dry pavement. So using the line graph, we find 60 miles per hour. You go up to the point, you come over, it's going to be approximately somewhere below 400, 375 maybe is what I would say. Round to the nearest 10 feet, I would say maybe 375. I can't really tell from that graph right there. And then it actually gives a function for this. That's funny. Oh, it's not exponential, it's quadratic, right? Because it has x squared, which means it's going up, and it would also go up in the opposite direction to create your parabola. Okay, and this question is saying, using this function, find the required distance at 60 miles per hour. Okay, so instead of just estimating it, could you be able to find that exact point? Well, you just can enter it in to your calculator. Are they doing it for you? Oh, that's just A. You could just enter it into the calculator and substituting in 60 wherever you see X. Okay. If you did this right here, you could just enter this whole line into the calculator. You just have to be careful if you're doing this on your own that you're putting parentheses in the correct places so that your order of operations is happening correctly. And your output would be approximately 358. So I said 375. I was way on the high side for my estimating there. Your checkpoint 5 says to use the same line graph to estimate a car's stopping distance at 40 miles per hour. And then, so you can just look at the line graph and do that, and then use the actual function. So the same exact thing, you were just changing your 60 to 40. All right, and graphing functions. I feel like we just did this. They made their tables. I'm not going to spend too much time on this, you guys. They made their tables. They made their input. They made their output. And then they graphed this equation. And I think this is the blue one. Oh yeah, it says right there. Okay. They did the same on the other side. Okay, just plotting those points. Oh, they just wanted you to see that doing that's the same as the y equals. So you have your input, you have your output. I honestly wouldn't spend too much time on this. Go ahead and graph the functions down here. And the vertical line test, this is a fun one. I'm sure you went over this last year. How can you tell if something is a function? So something is only a function, you guys, if there is only one output for each input. You can only get one output for each input. So if I input -4, right? The line is only here. There's only one output. If I input a +3, the line's right here, only one time, right? However, if I input 0, I get an answer above 0 and I get an answer below 0. So that means this line or this curve could not be a function because it does not pass what we call the vertical line test. So if I drew a vertical line, well, it was a terrible vertical line. If I drew a vertical line through there, it would cross more than one time. So it is not a function. Okay, so if you look down here, you can tell for A, it crosses twice, not a function. You can tell for B, only crosses once, and yet check a couple of places if it only crosses once. Because remember up here, if we would have just used -4, it only crosses once, right? We would have been like, oh, it's a function. Nope, you have to check multiple places. Let's see, C, nope, only crosses once. So it is a function. And Y, well, that's once, but then it's twice over here and none over here. So D, sorry, I said Y, it's weird. D is not a function. So A and D are not functions. Checkpoint, just figure out which of those are functions and which are not by drawing your vertical lines. Oh my gosh, you guys, there's more. I started this too late. In the evening, I am tired. Analyzing a graph. I think this is the last piece of information that we're going to learn for 7.1. So we are almost done. Too late for that flu shot now. Oh, that's hitting a little too close to home during the pandemic, isn't it? It's only 8 a.m. and you're feeling lousy. Fascinated by the way that algebra models the world. But that is true. I mean, just think about how many times you've looked at curves of the coronavirus. You construct a graph showing your body temperature from 8 a.m. through 3 p.m. You decide to let X represent the number of hours after 8 a.m. and Y represent your body temperature. So what's happening is at 8 a.m., you have a temperature of 101. At 8, 9, 10, 11. At 11 a.m., you have a temperature of below 99. However, at 1, 5 represents 1 a.m. because it's 5 hours after 8. Your temperature goes back up to 100 and it stays there at 3 p.m. the last time you take your temperature. So we figured out what is your temperature at 8 a.m. Part B, during which period of time is your temperature decreasing? Well, that is between 8 a.m. and 11 a.m. It is decreasing between, I'm looking at the graph now, 8. See how it's going down? It's decreasing between 8 and 3 hours after 8, which is 11. Estimate your minimum temperature during the time period shown. So the lowest it gets is approximately 98.6 or 7. Interesting fact, I heard the guy that was creating the thermometer had a fever when he did it, so that we should actually have a lower temperature than we do. You're going to have to fact check that. I think I just heard somebody say it, but that would make sense because I feel like I'm always lower. So we just did C, D, during which period of time is your temperature increasing? Well, that is from 11 all the way until 1, right? That time period right there from 11 to 1. And part of the graph shown is a horizontal line segment. What does this mean? This horizontal line segment just means your temperature is staying that way for those 2 hours. Explain why the graph defines y as a function of x. So this goes back to what we learned in science, where we have a controlled and a manipulated, right? So I think it is dry mix, right? D-R-Y-M-I-X, dry mix. So on the y-axis, you have the response variable and the dependent variable. And on the x-axis, you have the independent variable and you have the, oh, what does the M stand for? Response, manipulated and response. I think that's what I was just talking about. Okay, so I think it makes more sense to think about it in terms of D and I, of dependent and independent. Your independent, okay, I usually say it's what you know what time it is, right? What you need to find out is your temperature, right? I know it's 8 a.m., then I need to take my temperature. I know it's 1 p.m., now I need to take my temperature to figure it out, okay? It's not that you know your temperature is 101 and you need to find out what time it is. I mean, I guess there could be something like that, but it really doesn't make any sense in this situation. Okay. Your checkpoint 8 is just interpreting this graph here. Okay, same thing we just did. Whoops, thought I was still in highlight mode. Yay, and we are done. Give yourself a pat on the back, have a snack, take a break if you have more work to do. You did a good job. I look forward to seeing you. Please make sure you write down any questions for me that you